My name is Huub Schuurmans. I'm a chemical engineer and I'm working at the Equipment Engineering Department at KSLA.
My name is Nel Koelewijn. I have a PhD in organic chemistry. I'm a department head at KSLA. My department is working in the area of product research and development.
My name is Dick Wyfe. I'm a graduate from Leeds University. I got my PhD there in 1972. I joined Shell in 1976 in Sittingbourne. I moved here to KSLA in 1979. I now work in a process department here.
KSLA is the Royal Dutch Shell's Amsterdam Research Centre, and the administrative building is now a familiar part of the city's skyline. The site lies across the River A from the central station. And many of the 1,600 employees commute by ferry. KSLA is the largest of a number of Shell research laboratories outside the United States. Several of these are situated in Europe. Others are located in Japan and North America. They house around 7,000 scientists and technologists who are extending our scientific horizons, looking for new materials, processes and products which will ensure the Shell Group's continued profitability in years to come. From exploration for and production of hydrocarbons, research and development of oil and chemical processes, to product research on fuels, lubricants, agrochemicals, biochemicals, polymers, catalysts, detergents and metals, the range of research topics is very wide. In this laboratory, within the framework of process, product and engineering research and development, about 35% of the work comes under the heading of fundamental and exploratory research. 55% is development, and 10% is on technical support for existing products and processes. Let's begin with fundamental research. Here, we are continually seeking new compounds, devising improved reactions, and developing catalysts so that new processes or products can be achieved. Dick Wyfe has spent many years in this field.
In fundamental research, you're thinking about the quantum jumps in chemistry, about pushing back the horizons, developing new concepts and making new inventions. In exploratory research, then you're taking the new inventions from fundamental research, and these will become the new products or the new processes later on. We screen the project very carefully. We want to know whether it's a desirable product. We want to know about the reaction in the marketplace. And we also want to know what is the economic situation for the product.
Fundamental research, in the first instance, involves a great depth of knowledge and insight into the information already available in published scientific literature. There are direct links with databanks in all the other Shell laboratories, and with many other important sources of information, like universities and scientific institutions. Seminars and congresses are attended frequently. Universities visited. Papers published. There are lots of opportunities, formal or informal, for discussing ideas. Most project teams at KSLA are multidisciplinary, and the close cooperation between scientists with different training and experience is a critical factor.
You can expect to find just about everything you want here. You have a workforce with a very broad range of expertise from many nationalities. In terms of equipment, if there's something which you may not have, it's just one telephone call away. It's a very good site.
Nowhere is this factor more important than in the analytical department, which contributes to most of the research work at KSLA. Experts who are internationally respected work here with the latest analytical technology. And if what is needed is not available off the shelf, we develop our own techniques. Here, nuclear magnetic resonance is being used. This is one of the most powerful analytical techniques, and KSLA maintains a large team of experts dedicated to it. Process development is a key part of KSLA's research program, both in oil refining and chemical manufacture. Many plants the group is now operating around the world, for example, the gasification of coal or production of needle coke, started life as concepts or ideas which were developed at KSLA. Our expertise in the use of catalysts played a major role in these developments. This microflow installation is testing a variety of catalysts to see which produce high selectivity in a target reaction. New catalysts may be needed when an existing process has to be applied to more difficult feedstocks, or when an entirely new process is being investigated. One such process has recently moved out of the laboratory and is going to be implemented at Shell's Pernis refinery. The Hycon process will produce more light distillate fractions from the heavy residual oil after it has been through the conventional refinery processes. A new step in whitening the barrel of crude oil and a major achievement for the KSLA team. The advent of new technologies also creates opportunities for developing new processes. For instance, the application of biotechnology or electrochemical methods. In this installation, we are experimenting with fluidized bed electrolysis. It's currently an area of interest for Huub Schoolmans.
At the moment I'm working on the metals activities of the group in close cooperation with the Metals Research Center at Arnhem and here at KSLA with the mathematics department. And together we set up mathematical models of physical processes, and they help us with the solving of these mathematical equations. For instance, if you have a reactor in which complex chemical reactions are going on in several steps, you want to predict the yield of a particular component.
Promising results from these small-scale experiments can lead to larger-scale investigations. This pilot-scale setup has been built to test the viability of winning liquid fuels from biomass. The economics of the process are a key factor, as well as the testing of different engineering concepts.
Hello.
Engineering research is important in many different projects. Here, a membrane only a few microns thick is prepared for use in new gas separation experiments. In this technique, the desired gas separation takes place by molecular diffusion through the membrane. There's no need for added energy input, as there would be in a distillation process, for example. Increased emphasis is also placed now on environmental aspects, such as biological wastewater purification, desulfurization of fuels and flue gases, and reduction of nitrogen oxides in internal combustion engines. This experiment is studying factors which affect the exhaust gas emissions of motor vehicles.
Dus dat geldt hier misschien ook voor. Misschien zullen we een apart moeten ontwikkelen.
Decisions on the commercial viability of a new process are made by a wide circle of people, not only from the laboratory, but also from other departments.
Nou, ja, op het ogenblik vind ik dat wel moeilijk te zeggen, want de meting en melding duurt ongeveer 6 minuten, minimaal.
Economists, marketing people, equipment engineers, materials specialists all make a contribution.
Dus dat betekent dat je bovengrens waarschijnlijk bepaalde door je
Process development represents a great challenge to many who work in this field. Huub Schoolmans again.
Well, if you have a good proposal and it's of relevance to the business and accepted, then there are hardly any limitations. I mean, financially, or the kind of equipment that you need, or the kind of people that you want to talk with inside the organization or outside the company. For instance, I went to a symposium on plasma technology just to see what the state of the art is, whether this technology is being developed sufficiently to be of use of us in our own project.
Huub's question was answered with the setting up of an experiment on plasma polymerization. The results are expected to open up opportunities in the development of polymers with new properties. The science and technology applied in process research are, of course, equally relevant to products research. The results make this area of activity the most visible from the outside, as many products originally developed here are now in everyday use the world over. Oil products, detergents, polymers, resins, bitumen, agrochemicals, catalysts, composites. The list is continually growing. The research may involve investigations on the microscopic or molecular level, looking for new compounds with either specific properties or with a variety of new applications. It may include testing already developed materials to establish better manufacturing methods without adversely affecting the product properties. One example is epoxy resin coating, widely used by industry the world over. The technique of powder coating is highly efficient and uses no solvents. It is environmentally more acceptable. Two factors are significant here: practical performance and high added value. Effective product research is vital in maintaining the group's long-term position in the marketplace. To Nel Koelewijn, the challenge is clear.
First of all, we have to know the relationships between process or manufacturing conditions and product properties. Secondly, we have to relate these product properties to real-life performance of the product. Next to this work, which is building up experience and knowledge, we do basic studies, and these are aimed at understanding the processes that are going on. In this way, we are able to collect new knowledge, which enables us to do a better job next time when we design a new process or a new product. In addition to that, I should mention the cooperation which we have with universities and technical institutes. In common research projects or in sponsored research projects, we can learn a lot from the people at these institutes. Furthermore, we publish very often the results of our own work. In this way, we get a two-way information flow and everybody can profit from what we are doing.
At any given moment, the research underway will employ a very wide range of scientific disciplines. Some traditional methods, some the latest in analytical techniques coupled with computer sciences. But in the end, it is the people, the human factor, which decides the quality of the work and the effectiveness of the laboratory. So, what sort of relationships are built up by the KSLA research teams?
Well, two things I would like to mention: informality and mutual dependence on each other. Most people here are experts, and each expert contributes his or her expertise to the project of others. The heart of research project is a graduate, a project leader, together with a small group of assistants. And this team is working together, and only as a team they can be successful.
I think the research assistants are very important, more important than a lot of people realize. They are the people who are doing the experiments. They are making the observations, and they can often come up with very good ideas. I try to give them as much freedom as possible to do their work in their own way.
And what about career prospects at KSLA?
For many people coming from university with a technical background, research is a logical starting point in a big organization like Shell, unless, of course, they come with a specific interest in marketing or in finance or in other non-technical parts of the business.
As a student, I already had a rather vague idea of what it is like to work for a company like Shell. Research was a logical starting point because the work resembles closely what you are used to at the university. At the same time, you have the opportunity to look around in the company, to get to know the company and the opportunities that there are. What I did not realize was the large amount of freedom that you have in research to organize your work your own way.
I think you really have to know where it is you're going, what you're going to do, and how you're going to get there. The company is very big, as you know. It's a multinational, and your chances are equally big. It's really up to you and how much you're prepared to put into developing your own career.
Of course, there are a lot of people who have an international career within Shell, but it's not necessary to go abroad to find an interesting job. There are lots of interesting jobs within the Netherlands, here at Amsterdam, The Hague, or at the refinery. But if you want an international career, Shell offers a good opportunity, I think.
I'm still a visitor. I recall when I first came to the Netherlands, then I wanted to learn the customs. I started to learn the language. In fact, the language, I think there are 3 levels in the language development. The first is understanding or reading the language. The second one is getting engaged in conversation, getting your point of view across. And the third one, which I certainly haven't reached yet, that's winning an argument in Dutch. But looking back along the whole exercise, learning the customs, honoring the customs, talking with my colleagues in their own language, that's what makes friends.
So, within the broader confines of the Shell Group, career possibilities are very wide. Even within KSLA, the options are unusually varied. The multidisciplinary approach, involving the close collaboration of people from different backgrounds, leads to continual scientific and intellectual challenge. Meeting this challenge needs people of the highest caliber. Finding such people and getting the best out of them is essential if KSLA is to continue its vital contribution to Shell's future strength.